In this video, we'll deal mostly with word problems, so here's some real world problems. And then also taking sentences and turning them into equations before being assigned the new homework. So we've done enough where we just practice problems, so let's go ahead and read through this space travel problem. Neil Armstrong's spacesuit weighed about 33 pounds. An item's weight on the moon is about 1/6 of its weight on Earth. What was the weight of Neil Armstrong's suit on the moon? So we need to find out the weight. And as you probably know, you've seen moon video, and when somebody is jumping on the moon, they end up dealing with less gravity, so their weight would be less on the moon. I'm bringing that up only because as you do this problem, what you find out should be the same as what makes sense to you. So let's compare the moon weight somehow to the weight on Earth. So I know they're not equal, but I'm using that equal sign and on purpose giving myself some room out front to write. And the reason I say that is because I know that I can either take 1/6 and write it here, or I can take 1/6 and write it here. So I'm chunking the problem, I'm breaking it apart, and I'm using words now rather than variables because I think it's going to help me see the bigger picture better. So the weight on the moon is about 1/6 of its weight on Earth. Well, if I just were doing a problem from the previous section, well, I'd be like, well, it's got to be 1/6 of the Earth weight. And then as I try to picture it, let's say this is a number like 60. Well, 1/6 of 60 would be 10, and that would work out to where this number was less. So I'm just looking at it from all different angles to figure this out. Now, instead of writing it with words, let's rewrite it again. And we'll use the letter M, lowercase, because that's more common. They see lowercase for variables, while we see capital letters for angles. And the weight of somebody on the moon, or something on the moon, is 1/6 of its weight on Earth. Well, if the spacesuit weighed about 33 pounds on Earth, by the way, then we're going to figure out that its weight on the moon is 1/6 of 33. Now let's see if we can simplify this at all. 33 and 6 I know are both divisible by 3, so when I divide this by 3 I get 11, and I divide this by 3 I get 2, so I'm going to write 11 halves. So there's my answer in fraction form. And since we are dealing with a real-world problem, it might be weird to write 11 halves pounds. So I know I told you that using fractions is the better way. But since we're at the end of this problem, I think it's going to be great to write 5.5 lbs. Now we don't have to be crazy detailed where we say 5.5 pounds on the moon. And then when I go through and I check this in my head, is this reasonable? Well, if it was 33, then our number should definitely be less. If we got 55 pounds, then that would not make sense. And I could check this into the original equation if you wanted, but I think checking it against the real-world problem is good enough, and it does not tell us that we have to show work for this check. If you'd like, you can try this on your own, but that being said, I am going to talk about this thoroughly anyway. Surveys. In a recent survey of 13 to 15-year-olds, so they're saying somebody that is either 13, 14, or 15, so that's the age group that's being tested. So maybe they're asking about video game habits or something that's unique to those people, right? And I know that it ends up saying texting in a second. You're probably like, well, they're talking about texting. I'm just bringing up something to frame you as you think about 13 to 15-year-olds. Like, what would they be interested in? 225... So this is the number. This is the actual number. Or about 9/20 of those surveyed said they text during movies. About how many people were surveyed? Well, the weird thing is, we got this number 225, and this is the smaller part of the whole. These are the people that text. So let's make some notes. 225 text. But then we want to know how many people were surveyed. And if I think about this, well, that means that if I were to draw a pie chart, some fraction a little bit smaller than half text, while the other chunk do not, and then the entire chunk, whoops, again, and then the other chunk is all that were surveyed. And this is in red just to help you clear things up if you're thrown off by the word problem at all. Okay, let's check this out. How many people were surveyed? So 9/20ths of some number. Well, 9/20ths of those that were surveyed, so how about I say 9/20ths of S is equal to 225. On this problem, I think I'm going to like to see this a little bit more in parentheses and then multiplied by 20/9. And I think I just like that because this is a fraction with numbers on top and bottom as opposed to just a straight up division problem. Well, I can see that this cancels S out. That's why I chose it. And then on the right side, I'm going to have 225 times 20/9. And when you go to punch this in, you always want to double check. Like, let's say that we had 25 in the denominator. That would cancel nicely. We don't have 25, so maybe as you try to think about dividing 225 by 3, then either it's more work or the same amount of work if you can pull out the calculator that quick. So you don't have to show it this way, because what I'm pointing out to you is sometimes that's actually more work. And when I say sometimes that's more work, well, because when you go to punch this in, you could keep on dividing and keep on dividing, or you could already be at your answer and figure out that there were 1,500 people surveyed. And I think this is clear enough to just say 1,500 surveyed, because it's not like we have multiple age groups like 13 to 15-year-olds and then 40 to 45-year-olds and so on. When I go to do a little bit of a sanity check, when I say sanity check, I'm making sure that my answers are reasonable. When I go back and I do a sanity check, I see, okay, well, 1,500 was more. About half of that is 750. And that makes me realize that I typed in the wrong answer. So there you have it, boys and girls. That is a perfect example of how I made a mistake, and then by going through it, I figured out that it didn't make sense, and I had to go back and double check what I typed in. And the other thing, too, is in overthinking that one there, I ended up plugging in a 9 with these numbers instead of a 3 with the original numbers instead of a 9. So that's a perfect example of how sometimes that's a poor choice. Okay, for the following, write and solve an equation. So we are going to write and solve equations using division. Always focus on the word is for these problems. Here's is as an equal sign. And it says negative 18 times a number is negative 198. So that's the challenging part, assuming that the division part feels comfortable. So I look at this, it's like, okay, well, we got the negative 18s being multiplied, but the opposite of multiplication is division. So I will undo that negative 18 by dividing both sides by negative 18. Now, it's always cool to try to do these without a calculator, but these are large numbers. So if you punch this in, you'll get 11. Now, although this doesn't say to, let's check it anyway. Negative 18 times 11 is hopefully equal to 198 when it's negative. Now, notice that I say hopefully, and the reason is because I know this is going to end up being negative 198. So I'm saying hopefully to remind you that this right side is not after you've punched this in. This right side is what it should be equal to if we have not made a mistake. So negative 18 times 11, we assume it's negative 198, but it defeats the purpose of a check if you're not getting out a calculator. So type it in or handwrite it to the side and show that 18 times 11 is 198. Negative 42 equals the product of 6 and a number. Instead of saying is, the new word here is equals. Negative 42, without anything else attached to it, equals the product of 6 and a number. This problem begins with multiplication, and the number attached to the variable is 6, so the opposite of multiplication is division, and when we divide this from both sides, I'm just going to fling the y to the left, make sure that I know that I have a negative divided by a positive, and then I get 7. When we do the check, negative 14 is not what I just wrote. Negative 42 is equal to 6 times negative 7. Negative 42 is equal to, well, 6 times 7 is 42, and a positive times a negative is positive. We're accurate. That takes care of it for all the different problems where you will see real-world word problems, as well as problems where you'll have to develop your own equation from words. Here's the section, and yes, I do want you to do all these problems. These things should be muscle memory. You should get in the habit of where you see something, especially a problem like 3x equals 6, and you're immediately like, okay, cool, I'm done. There we go. To where you can plug those in super crazy quick. Good luck with this assignment.